I'm Ben Levine, and with me is Talluri from Qualcomm. I'm with MetroLab, which is a national network of cities and universities that seek to bring technology and analytics to local government. And I think there are a few companies that are as active in that transformation as a company like Qualcomm. So I want to start with an important question that's been raised in the previous panels. From your perspective, can you just describe what the future city looks like?
Yeah, Ben, thank you very much. And really my pleasure to be here. Long time since I've been in DC, and it's a great city. Every time I come here, I realize how pretty it is. Smart cities, we spend a lot of time at Qualcomm in building basically the technology and the infrastructure that goes into connecting things like phones and things in the infrastructure of the cities. We think of smart cities as cities that are extremely convenient for people to live in, extremely efficient, so that you don't waste resources. Easy to get. I was sitting here listening to some of the panels. Transportation, getting people to go from place to place. Utilities and autonomous cars, the new things that are coming up. So places where all those things work seamlessly, and the people who live in the cities don't really have to think about whether they're smart or not. They're just more convenient to live, and that's kind of like how we look at it. There's a lot goes to building those, but that's kind of how we see it.
Terrific. And I think embedded in that question are two important technological transformations that are happening that are separate but related. And I wonder if you can dive into them. The first is the transition from 4G to 5G. And I think we're all familiar with 4G connectivity because there's a constant reminder in the left-hand corner of our cell phones. But I think that perhaps fewer people appreciate what's going to happen as we transition to 5G. Can you talk a little bit about that?
Yeah, for sure. Firstly, one of the fundamental things of making cities smart is connectivity. I mean, I think you have to make sure that things are connected to get most efficiency out of something. When I say things are connected, you can think about. I'll give you a simple example that makes maybe the point drive home. If you think about water and how we distribute water among cities in many areas, a lot of water does get wasted because at many of the junctions where the water pipes are, some water is leaking. And it's really hard to find out where it is. So you pretty much have to find out water is leaking and send someone out there to go look at every place and figure out where it is. But what we've been able to do in the last few years is build this technology, similar technology as we have in our phones, the modem technology. Let's talk about 4G as the last generation of it, where you're able to embed this little modem into the junctions where the water is. And whenever there's a little leak in water, we have some sensors that can detect something is leaking. And this modem will then send a signal that says, here is a leak. And then you're able to send people there and fix that. That's just a very simple example. You can think about the same for electricity. You can think of the same for parking and so many other ways. Now, there is one difference, which is when the technology that we use to communicate that, the 4G technology, the original 4G technology has been really built for phones, which means you wanted it to be in your phone, you pick it up and you talk, or you surf the web or whatnot, and you charge the phone every night. Now, when you put these things in infrastructure of the cities, you don't have the ability to charge them every night. So this thing has to last and be there for tens of years. So we came up with this, the standards body, a next generation of 4G technology called CATM, which basically stands for maybe more for the machine-to-machine communications. This is a small modem that sits in there, but it works on 2 AA batteries. It can send this signal when something happens and then go dormant and stay there for 10 years. So that's the version of 4G that's working today. Now, that's an adaptation of a 4G technology that was built for mobile phones. Now, as we fast forward and think of millions and billions of things that are connected, that technology, while it is sufficient and we're deploying it today, needs to evolve into something that can work when these many things are connected, and something that can be extremely low latency, and something that can give immediate access. So in 5G, we are trying to solve those problems that enhance the 4G technologies to really work well with this Internet of Things, when the many things are connected, and those are not just phones.
And can I jump in on so the second major technology trend is the Internet of Things. Can you sort of talk about what are the use cases that we're seeing? You mentioned the example with water leakage. Yeah. Can you talk more broadly in the context of cities transforming, how the Internet of Things will change cities?
For sure. I mean, the word Internet of Things itself now it's become quite common and a fairly generic thing. And you ask yourself the question, what are those things? We at Qualcomm like to think about that as things that in your home that are connected. These could be your set-top boxes, your TVs, your streaming speakers, your washing machines, your dishwashers, your thermostat, your security cameras, and so on. In the cities, you can think about these as anything that's deployed in the cities. It could be your water meters, it could be electric meters, it could be parking lights, it could be, the street lights, and signal lamps, and any of those things. When you are able to connect those, and when you're able to put some processing in those, you can do very, very interesting things. I'll give you a simple example. Actually, I was just thinking about this the other day. I was driving, and we all have these navigation systems in the phone that'll tell you. We got so used to it, we don't remember directions anymore. We just follow that thing blindly. It says turn left, you turn left. But the funny thing is, that thing says turn left here, but it has no concept if the light is red or green. So many times you find yourself someone telling you turn left, you're like, wait, this is red, I can't turn. But if you think about it, where that signal light is actually connected to your phone with your driving or to your car, it'll only turn left when it's green. So that's another interesting example of where we have all this information, but we don't have connectivity between these things. So we think of Internet of Things in the context of connecting all these things to each other and to the cloud, so you can get that kind of conveniences that you live in everyday life in the cities.
And will the advances in connectivity and, I guess, therefore, the advances in the Internet of Things, will that happen is this sort of in 3 years we're going to have this technology, or should we expect it to sort of be a constant transition? I know that there are attempts now to build test beds essentially around 5G technology.
Right. Well, it's happening a lot right now. It's actually already happening very, very fast. A lot of people don't see it. At Qualcomm, we said publicly that we ship over a million chips a day into Internet of Things right now. We've shipped over 1 billion have chips. So it's happening fast, and it's happening in a way that is fairly seamless, that you don't think about it. But it is happening right now. Like, as I mentioned, all the electric meters, all the water meters, we're replacing them all one at a time. So it is a gradual transition, and you will see it happen. And I tell people that if you think about homes or cities, you're not going to wake up one day and suddenly find, wow, my city is smart, or my home is smart. It's just going to be one of those things where gradually things get better and better and better, and it just becomes seamless. I'll give a simple example in the consumer space, which you'll actually think about it. So many of us use Spotify or whatever connected to speaker to play music. It just happened. Like you just stream music onto your speaker in the house. You don't think about where's my CD or anything. You just say, Alexa, play me this song, and it works. Right, so when did that happen? When did your home suddenly get smart to play any music you want? That's how it's going to be in the cities. It'll happen one step at a time. It takes a little longer than home because the consumer cycles are a little bit different. One way to do it, to answer your question, is to actually build a prototype of a smart city or something and deploy it there first, so people can kind of experience what it's like. But then from that, you take elements that work and you propagate them through the existing cities.
Terrific. I want to build on that a little bit. Kate from Seattle in the previous panel mentioned the fact that Bill Gates had bought property in Arizona to build a smart city. Sidewalk Labs recently made a big investment or commitment for an investment in Toronto to think about how they can develop a 12-acre smart city kind of area. I'm curious from your perspective, who's going to lead this transition? Is it going to be cities? Is it going to be developers? Is it going to be international countries? What do you see happening?
Yeah, it's very interesting. I think most of the time these kind of things, the way we see it happen is it happens. Definitely the municipalities and the administrative bodies of the cities will have a big say in how it gets deployed, when it gets deployed, and what methods we take to make sure these are safe and happen properly, for sure. But I also think people like Qualcomm will have to build the fundamental technology, and then our customers, like people like GE and Philips and so on, will make the products. So the rollout will involve many, many people. But building these kind of test beds is very important because we can prove out the technology. But when it's rolled out at large scale into the hundreds of cities or thousands of cities in the world, everybody will participate in it.
If you look back, say, 5 or 10 years, were you surprised at the growth or relative slowness of growth in particular sectors versus others? So was industrial IoT faster, for example, than local government smart cities deployments?
Yeah, I think it is true that the local cities, smart cities, local cities driving for change has been a little bit slower. But I don't know if I was so surprised as much as it just takes time with all the governments involved. But in industrial IoT, actually, if I step back a little bit, the fastest growth in IoT has been in consumer. Because if you think of the products you buy at home with the Nest thermostat or Amazon camera or whatever, you see how fast connected things are coming. The next one has been industrial, And industrial mainly because there are efficiency gains. So if you think about a factory that's automating it, for them to have all these connected products just gives efficiency gain. So there's a clear monetary value associated with that. So that is happening next. In cities, it just makes people's life better. And with that comes indirect efficiency gains and productivity and so on. So it's a little bit slower, but a little more indirect. But for sure, it's happening. If we have this conversation 5, 10 years from now, we'd be surprised how quickly we got there.
Terrific. Well, I think we're all appreciative of Qualcomm, whether we know it or not, in terms of the impact it's had on our daily lives and our technology usage. So, Raj, thank you.
My pleasure.
And I'd now like to turn it over to the Washington Post.
Yeah, thank you very much. My pleasure.